This video will cover section 4.2, part 2. So we are going to talk about even and odd functions, and I don't know if you remember, since you guys were in Pre-Cal 1 or Algebra 2, I used to tell you even and odd functions actually matter a lot, and it's not something that's going to go away, okay? It's going to keep reappearing over and over. So what we can see here, and I think we did a little bit of that with your unit circle, we were reflecting a point, right? So imagine that this point, it comes from this initial, from this angle. This is the initial side. This is the terminal side. And here's my angle right here. So it is positive t. We don't know how many degrees. It could be 45. It could be 47. We'll just call it t. Now, on this other side, we have another angle. And this one also in standard position because it starts at the positive x-axis. And this is the terminal side. So this angle, since it goes in this direction, clockwise, it is negative. However, it has the same measurement than the other one, but it's negative. So this one, we will call it negative t. So going back to Pre-Cal 1, when we discussed even and odd functions, we had a way to check for those. And we had established that we always had to find f of negative x. Do you guys remember? Plug in negative x and see what you get. So after doing all that, if you got exactly the same as the original function, you will say that the function was even, right? Do you guys remember that? And an example of that was like the quadratic function, right? And those were reflected across the y-axis. Now, we had odd functions, and we had to do the same process. We had to find the f of negative x, and if we end up with the exact opposite as the original, meaning all the signs were changed, and that's how we represent the opposite with this negative outside. So if you got something like that, then you will say the function is odd. And an example of that one was the cubic function. And those were symmetric with respect to the origin. Now, when we're talking about trigonometric functions, we're going to use this little example here to determine why some of those are odd and some are even. Okay? So what we're going to do is look at this point and this point. Now, you guys remember we said that the x-coordinate gives you the cosine, right? And the y-coordinate gives you the sine, correct? So if we look at that point and this point, so P and Q, you could see that what changed here is we're talking about a negative angle, which is this angle here, the one that I traced in red, this negative angle. So the coordinates here are cosine of negative t and sine of negative t. Instead of xy, we said cosine negative t, sine of negative t. For point P, we have cosine of angle t, comma, sine of angle t. All right. Now, if those were just numbers, what could you tell me about the cosine of t and the cosine of negative t? Will they be the same or will they be opposites? So I'm talking about this one and this one. In fact, they are numbers. We just don't know what number they are. Will those two numbers be equal or opposite? All right, let me ask you something. Will those two numbers be positive? Yes, we're talking about x values, right? So yes, both of them will be positive, and moreover, both of them will be the same, right? So what we can infer from here is that for cosine, since the x-coordinates of cosine of angle T and cosine of negative T are equal, then we're going to say that the cosine of T is equal to the cosine of negative T. And because of that, cosine is even. I'm just going to give you a number. Let's say that here we have a 1/2 for the x-coordinate. This one will also be 1/2, positive 1/2. Okay, just a random number. Now let's look at the sine value, which comes from the y-coordinate, right? Now, if you look at the y-coordinate here and the y-coordinate here, would you say they have the same sign or opposite signs? Opposites, right? Because here the y is positive, here the y is negative. So the y-coordinates are opposites. Therefore, the sine of negative t is equal to the opposite of the original sine of t. And therefore, sine is odd. Jonathan, is there like a light blue marker somewhere? Oh, I see it. Okay, now do you guys remember that thing about symmetry? Even functions are symmetric with respect to what? The y-axis. Remember how I told you this were the weights for the sine and cosine graphs? Yes. Cosine, even, right? This is even. Isn't it symmetric with respect to the y-axis? Yes. And even if you extend it, you keep going in both directions, it's the same thing. It's always going to be symmetric with respect to the y-axis. Okay? Now, sine is kind of similar. If you look at the cubic function right here, x cubed, it is similar to this one. If I was just to trace this part here. Doesn't it look similar? So yes, that is an odd function, and it is symmetric with respect to the origin. All right? Okay, so right here we have just a summary. And so we have that. Remember how we talked about about cosine and secant being reciprocals, right? So since cosine is even, also secant will be even. All right? Cosine and secant. Now, since we already found that sine and it is odd, then sine and cosecant are also reciprocals, so that's why we can find cosecant here. Okay, now tangent, it is also odd, and I'm going to say that one. I'll show you why it is odd in a minute. Okay? And so also cotangent will be odd. All right, let's go to the next slide. So by using that notion, we're going to complete the example 4. I will do example 4, and then you guys will do checkpoint 4, okay, on your own. So we already established that cosine is even. So because cosine is even, we're going to use that to find the value of cosine of negative pi over 4. So cosine of negative pi over 4 is equal to the cosine of pi over 4. Yes or no?
cosine is the x, so it'll be 3 times.
So you could use your unit circle if you don't remember what it is. So can you guys tell me what is cosine of pi over 4? Huh? Oh, well, no, I'm not asking about the angle measurement. I'm asking about that fraction, that ratio. So more specifically, that x coordinate that you have on your unit circle at pi over 4. It should be somewhere in the first quadrant. Yes, square root of 2 over 2. So we know that's the value for cosine pi over 4, but it's also the value for cosine of negative pi over 4. All right? Okay, so let's do the second one. So in this case, I know you might be a little confused. The input will be the angle, and then the output will be the ratio, okay, the trigonometric ratio. All right, now for part B, tangent is odd. And so we have tangent of negative pi over 4. We cannot say that it will be the same as tangent of positive pi over 4. It is actually the opposite, right? The opposite of tangent of pi over 4. So do you guys remember what is the tangent at pi over 4? Let's find it. Okay, so Samantha, tangent is defined as the ratio between the y and the x so far. In a minute, you're going to see another ratio. So could you tell me, Samantha, what is the y coordinate at pi over 4? Look at your unit circle. Did we wrote those down, right? Okay. Were you here, Sam? Yeah, okay. Can you guys help her out? So which one?
The x, right? The y one or
The y first?
Square root of 2.
Okay. And now tell me the x.
Square root of 2.
Okay. So when we divide this one thing by itself, what do we get? 1. A 1. So to answer this question here, we're not going to say that it's just 1. It's actually going to be negative 1. Okay, so now I want you guys to work on checkpoint 4, and I want you to consider the following. Secant is even. That means it's going to be the same as the secant of pi over 4. And then sine is odd. So you will have to use the opposite of sine of pi over 4. We're going to check our answers for here at checkpoint 4. We have part A, secant is even, so we're going to use secant of negative pi over 4 is exactly the same thing as the secant of pi over 4. And so the secant of pi over 4 is going to be the square root of 2. If you don't remember how to get that, you could consider cosine of pi over 4 is equal to the square root of 2 over 2. So secant will be the reciprocal of that, which will be 2 times the square root of 2. So then we need to rationalize the denominator, and after doing that, we will get 2 times the square root of 2 over 2, and here that turns into a 1, so the final answer will be the square root of 2. For part B, sine is an odd function, correct? So the sine of negative pi over 4 is going to be not the same as sine of pi over 4, but the opposite of the sine of pi over 4. And so the sine of pi over 4 is equal to what? Okay. Square root of 2 over 2 Well, we need the opposite of that, so negative square root of 2 over 2. All right, let's move on to the next slide. Now, you guys know I've been using the term reciprocal a lot, right? So, and I tell you, you flip them. So this is another way to look at them. So it will be one divided by the other. Now, I know that when I use the term reciprocal, I'm usually giving you numbers like 2/3. What's the reciprocal of 2/3? 3 over 2. And you're so good about doing that. But maybe I've been just taking a shortcut. So if I was to get the reciprocal of 2/3, I'm going to do that just so that this makes a little sense to you, okay? So let's pretend that we do 1 over divided by 2/3. So if we use that sandwich rule that I taught you, you guys remember, yes? So you multiply the outer quantities, you get a 3. You multiply the inner quantities, and you get a 2. And we get the same, right? The reciprocal. So this is how we're going to represent the reciprocals. Now remember I told you sine and cosecant are reciprocals of each other. Secant and cosine also reciprocals of each other. And so are tangent and cotangent. Now, when I took this class, I used to think to myself, why didn't they make sine and secant reciprocals, right? Wouldn't it make more sense? Like they sound more alike, I think. But they didn't, right? And that's something we cannot change. So I'm going to, a way to remember which is the reciprocal of which, you can think of this. You're going to have an S and a C and an S. All right? Like one of each. CS, SC. All right? Those are the reciprocals. And because of this identities, we're able to do that, flipping the numbers like we've been doing during class today and the previous one. All right? Okay. So here we have something else called the quotient identities. And so quotient implies division. All right? So before we got to this slide, we were considering that the tangent of an angle was given by y over x, correct? But isn't it defined sine of that angle as the y coordinate right here? Yes, sine is the y coordinate. And what is cosine? The x coordinate. So it makes sense that we replace the y coordinate with sine and the x coordinate with cosine. All right? So that is one of the quotient identities. Stuff on this box we need to memorize. Stuff on this box also memorize. Now, if we have the quotient identity for tangent, we should also have one for cotangent. And just to remind you a little bit, cotangent was defined as x over y, right? So doesn't it make sense that we replace x with cosine and we replace y with sine, all right? Furthermore, we could say that cotangent was the reciprocal of tangent, right? So if we're flipping them, it makes sense that we say for tangent is sine over cosine. So cotangent will be the reciprocal of that, which will be cosine over sine. Cassandra, you're looking at me like, what is she talking about? Okay, that makes sense? Okay. I promise you that we're going to use this so much that it will make perfect sense to you. The more we use them, and of course, your homework is very important. Now, remember how I told you, I'm going to show you why tangent is odd in a minute, right? So let me go back to that one. Now that we have this identity, that's what I'm going to use to show you why tangent is odd. Did I say even? Odd. Tangent is odd. Yes. many slides do we have left? Is it an emergency?
Yeah.
Okay, go. Okay. So we got the tangent is the sine over the cosine, correct? Yes? We got that? All right. Now what if I want to find tangent of negative t? So that will be, by definition, by the quotient identity, it will be the sine of negative t divided by the cosine of negative t. Correct? Yes or no? Yes. Now let's look at this one here. And I want you guys to tell me, by this table, since sine is odd, what does sine of negative t equals to? Right here, right? Negative sine t. Okay, by this table, again, what does the cosine of negative t equals to? Cosine of t, right here. So, what we get from here, it is negative, what is sine over cosine? Tangent of t. Okay, and so that's how we get, we could demonstrate that tangent is an odd function, because we started with the tangent of negative t, and we ended with the opposite of the tangent of angle t. Okay, look at it for a second. Would you like me to repeat it? Rephrase it. Okay, so I started with this. By the quotient identity, oops. The quotient identity from that slide, we have this, right? Tangent is the ratio of the sine over the cosine. Now, if I want to find out what is tangent of negative t, just to prove that I will get that, let's say this is a question. Is that true? So I'm substituting the angle with a negative angle. Now, by definition, if I was trying to find the tangent of theta, it will be sine of theta divided by the tangent of theta. But in this case, what I was doing is trying to find the tangent of negative t. So because of that, I replaced the angle here with negative t.
I have a question.
Yes.
Wouldn't the bottom one be cosine?
The bottom one will be cosine. Yes. I'm sorry, Brisa. But thank you for paying attention. Yes, that will be cosine. So going back to this one, so I'm substituting the angle with a negative angle. No big deal. Same here and here. Still the quotient identity, sine, cosine, sine, cosine. When I get to this part, what I did was asking you guys, what is the sine of negative t is equivalent to? And so the sine of negative t is actually equivalent to this. So that's what I replaced on this part. Okay? Negative sine of t. You're not going to be quizzed on this. I'm just showing you why. So just relax. Okay? Now, the cosine of negative t, if you look at this table here, what does that equal to? And then Ruben told me. Cosine of t. So that's what we replaced here. All right? Now, the only thing that I did was that I factor out the negative sign. Is here. I have some colors now. This negative sign here is right here. And now this part here, going back to this one, what does that equal to? Tangent of t. All right? The whole idea behind this is that since the tangent of the negative angle, what we started with, is equal to the opposite of the tangent of that angle, but positive instead. Because of that, we could say that tangent is odd. All right? I'm just doing that to show you that that is true. That's it. You're not going to be tested on it. Okay? All right. I'm going to go back to the other side where we left off, right here. Now, we have 3 more identities there. And these are called the Pythagorean identities. Why do we call them that? Because if you remember Pythagorean theorem, it goes something like this. A squared plus b squared is equal to c squared. Right? Okay. So now what we do is we take the sine square of that angle, we take the cosine square of that angle, and that is going to equal to 1. All right? Now, I should have gone over that proof, but I didn't, so I don't want to do it wrong. So let's see. I'm just thinking. All right, let's take, for example, the equation of the circle. It is x squared plus y squared is equal to 1. Correct? Yes? The unit circle. Now, because I don't want to confuse you that sine is x or y, whatever, I'm going to switch the order because we already know that sine comes from the y value. And so we get that. So now the Pythagorean identity right here, it's got to come from the equation for the unit circle. Now, for example, let's take the angle Okay, so this is a little proof of the Pythagorean identity, how we get it. And so we use the equation of the unit circle, which is here. We use the angle t equals pi over 4. So if we get the sine square of, the sine of pi over 4 is the square root of 2 over 2. The cosine of pi over 4 is the square root of 2 over 2. If we square those two quantities, we will get 2/4 plus 2/4, which equals 4/4, and that is equal to 1. So that kind of proves why the identity works and where it comes from. Now, from that identity, I can tell you that that is one of my favorite identities. And I actually call it the lifesaver. Trust. You will too. Because every time you can find a sine square and a cosine square, you can cross them out, they're adding, and just turn it into a 1. That's why we're going to call it a lifesaver, all right? Okay, now from this Pythagorean identity, we get the other two. This one and this one. So those are actually just variations of the very first one. We're not going to use them that often, but you will encounter them. And so it's still useful to know them, all right? Now, to be honest, 100% honest, I don't know them, like, exactly. Like, I'm always doubting myself. Was it plus? Was it minus? For this two. But I know how to derive them, all right? And so let me show you how to do that. I just want to know which one I want to do first. Okay, so let's start by dividing by cosine. So let's divide this into 2. So we start with sine square of t plus cosine square of t is equal to 1. And I want you guys to divide all across by cosine square of t. Alright. Now Andrea, by the quotient identity, okay, it's on your slide. What would you say sine square of t divided by cosine square of t is equal to? Tangent square of t. Very good. Now, so Sydney, what is cosine square of t divided by cosine square of t? 1. And Annette, by the reciprocal identities, what is 1 over cosine square of t? Look again. 1 over, starts with an S.
Oh, the sign?
No, no.
Other one, right? Secant.
Secant square of t. I mean, secant square t. And so that one is here. All right, let's look at the other one. So we start again with the first one, the Pythagorean identity, sine square of t plus cosine squared t is equal to 1. That's what we start with. That's it. Now I want you to divide by sine squared t. Everything, all across, left and right. Okay. Jonathan. No, that's too easy. I'll do this one. Sine square of t divided by sine square of t, what does that equal to? This one. All right, now Jonathan, look at the quotient identities and tell me what is cosine square t divided by sine square t. COT? Cotangent. So cotangent square t. At least you didn't say cot. That's good, Jonathan. All right, and then Jesus, I want you to look at the reciprocal identities and tell me what is 1 over sine square of t.
1 over.
Oh, 1 over sine. On the table, I will just say 1 over sine is equal to. You could spell it out for me if you want.
Yes.
CSC, so that will be cosecant. So since we start with sine square, we must have cosecant square, okay? Now, this little square is a little technicality that you are going to have to be careful with, because what it actually means to say sine square of t, we're not squaring the angle, okay? We're actually squaring sine. So this is equivalent to sine of t multiplied by itself. That's what it's equivalent to, all right? I don't want you to think that the square belongs to the angle. It belongs to the whole operation sine. By the way, something that I have not told you yet is that sine by itself has no meaning at all. Nothing at all. You must have an angle that goes with it, okay? Keep that in mind, please. Always an angle. It could be t, it could be theta, it could be x, it could be any variable. Most of the time we use Greek letters for that. Okay, so let's go back to the other one. So this one right here, it just proves how this one came about, okay? How it's derived from the Pythagorean identity. Okay, so we're going to move on. All right, now, using those identities, the quotient and the reciprocal, we're going to find the trigonometric functions here. So remember quotient and reciprocal, all right? So we already have sine of t is equal to 2/5. So since cosecant is the reciprocal for that, what will that be? Pretty easy. We just flip them. So what is it, Brandon? 5 over 2. You guys see, I always line them up like that. I just kind of get used to it. All right, now cosine of t is here given to us. Square root of 21 divided by 5. So since secant tangent is the reciprocal of cosine, what would the value be, Jennifer?
5 over square root of 21.
Uh-huh. And then we need to rationalize, so we multiply by the square root of 21, top and bottom, and we will get 5 times the square root of 21 divided by 21. Now for tangent, we're going to use the quotient identity, the one that tells me that it is sine of t divided by cosine of t, or y over x. So the sine of t is 2/5. The cosine of t is the square root of 21 divided by 5. So in this case, we can multiply the outers. 2 times 5. Without multiplying them, you could just leave them as factors, a lot easier. And then 5 times the square root of 21. In this case, we could cancel the 5s because they're factors. And we will get 2 divided by the square root of 21. However, we need to rationalize. So this will be 2 times the square root of 21 over 21. This is the answer. Now we have one more to go because there are 6 trigonometric functions, and that is cotangent. And so for that one, instead of taking the reciprocal of this answer, I'm actually going to take the reciprocal of this one, the one right before I rationalize this answer right here. It will be a lot easier. And so for that, if I just flip those two numbers, it will be this, square root of 21 over 2. Whew. All right, now example 6, we have to use the Pythagorean identity for this one, okay? And you have like a couple of questions like that on your homework. They're not too difficult, so don't be scared. All right, so we need to find the value of the cosine of t using the Pythagorean identity. So what is the Pythagorean identity, Yvette? Pythagorean identity, just read it for me.
Oh, sin.
No!
Sine, sorry.
Sine.
Square
Uh-huh.
t
Uh-huh.
plus cosine
Uh-huh.
2. Square.
Is equal to
1.
1. Okay. Now let's go ahead and substitute the values that we do have. And we have this one right here, right? The sine of t is equal to 3/5. So once we substitute, you don't need to write sine again, okay? It's like we take this one and we substitute it with the fraction, just the number. So it will be 3/5. However, we're squaring that, so we need to square this fraction. And this is why it's important that you study your notes before you take that exam, okay? Plus the cosine square of t is equal to 1. All right, so now what is 3 squared? 9. 5 squared is 25. Okay, so remember, we're solving for cosine square of t. Oh, I'm sorry, more specifically, we're solving for cosine t. So we need to take care of this 9/5, which is adding to the cosine. So we're going to take it across to the other side, and it will be subtracting, doing the inverse operation. So cosine square t is equal to 1 minus 9 over 25. Now we get into fractions. So 1 converted into 25ths, it will be how many?
25.
So then the cosine square of t is equal to, thank you. And now what is last for us to do? Square root, yes, square root. And remember here, we will be taking the square root of 16 and the square root of 25, okay? Now the question is, should we take positive and negative? Well, the square root of 16 is 4, the square root of 25 is 5. To answer that, we need to look at what's happening here. If we are saying that our angle is greater than 0 but less than pi over 2, which quadrant are we talking about? First quadrant, okay? So right here, remember, this is 0, and this is pi over 2, or 90 degrees. So that means that our angle needs to be somewhere here, okay? So in this case, will the x and y be positive? Yes, right? X is positive, and the y is positive. So in this case, the cosine for that angle and the sine for that angle are both positive. So because of that, we will only take the positive 4/5. Okay, so we only take the positive square root of 16. Remember, we don't do the plus minus thingy. Now, if the question had said something like, we want the cosine to be in quadrant 2, it's right here, we want the angle to be in quadrant 2, then we will have to do some adjustments. Okay, then the cosine will be negative instead. I know it's a lot of information, guys, I know. When I took the class, this class, I actually thought it was hard. But I used to do my homework every day. Huh? I got an A? Let's go to the next slide, and now we're going to talk about something called periodic functions. And just like I told you, you can keep doing rotations. And just like, remember what we said about coterminal angles? For example, pi over 6. Right here, pi over 6. Is coterminal to, what about if I do a full rotation and then I go another pi over 6? What would that angle be? Let's think about it. A full rotation is 2 pi, this is 12 pi over 6. So if I go an extra pi over 6, how many pi over 6 do I have? 13. Very nice. So those two angles are coterminal, right? So because of that, they are going to have the same values for sine and cosine and tangent and cotangent and all of those. So the sine of pi over 6, remember that's my favorite, sine of 30 is 1/2. I always know that one. And you should too. Sine of 30, 1/2. Okay, I'm going to keep asking. Every time I see you out there, I'm going to ask you what's the sine of 30. Yes. 30 degrees is the same as pi over 6.
Oh, I see.
So because of that, the sine of 13 pi over 6 is also 1/2. Okay? So that is what periodic functions are going to be talking about. And so the period, we're going to denote that with that lowercase p. So for sine and cosine, the period is going to be 2 pi. So the trigonometric values will repeat every 2 pi. Okay? Now with tangent and cotangent, it's a different story. I don't know where Karina put it. Look in those boxes over there, please. It's great. Or maybe she put it in the cabinet. All right, now with tangent, it's a different story. With tangent, the period is not going to be 2 pi. The period is actually going to be pi. Now, let's just, I think we're ready to do this. Remember how I always go in this order, right? Sine, cosine, tangent. Yes? Sine, cosine, tangent. Sine, cosine, tangent. It's like a little song. Sine, let's give an angle, is the y, cosine is the x, and tangent, of course, is the y over x. So let's think about it. Quadrant 1. Is sine positive or negative? Y is positive, right? What about quadrant 2? Is the y positive or negative?
Positive.
How about quadrant 3?
Negative.
Quadrant 4?
Negative.
Okay, now let's do cosine. So the x, is the x positive or negative in quadrant 1?
Positive.
How about quadrant 2?
Negative. Negative. Oh, negative. I'm sorry.
The x. How about quadrant 3?
Negative.
Quadrant 4?
Positive.
Okay, now let's do tangent. Now tangent is a division, right? So what happens when you divide positive over a positive?
Positive.
What happens when you divide positive over negative?
Negative.
What happens when you divide negative over negative?
Positive.
What happens when you divide negative over positive?
Negative.
Okay, so that is how you're going to determine your signs. Okay, that's a very quick way to do it. My students, what they used to do as soon as they got their test, they used to write this down in the unit circle. They'll like just draw it like by instinct. All right, so the period for this one, here's a little drawing. I don't want to get too into detail with this because we're a little behind. But if we were to consider an angle here, such as, let's use pi over 4, why not? We like that one, right? We like that one because the sine and the cosine are the same, isn't it? So here, let's say the t is pi over 4, so the coordinates here will be square root of 2 over 2, square root of 2 over 2. What will those coordinates be over here for that same angle? And I'm talking about, it will be pi plus pi over 4, so that is 5 pi over 4. So at that angle, the coordinates will be negative square root 2 over 2 and okay. However, this is sine and cosine. Sine, cosine. What will happen when I divide negative over a negative? I will get positive. So what that means is that every pi radians, the values repeat. Okay? So in this case, the tangent of pi over 4 is 1. But so is the tangent of 5 pi over 4 is also 1. Okay? All right. Now let's do the exercise. All right. So let's keep this in mind. For sine and cosine, the period is 2 pi. For tangent, the period will be pi. Now, what is the reciprocal of sine? Cosecant. And what is the reciprocal of cosine? Secant. So also for those two, the period is 2 pi, okay? Now, what is the reciprocal of tangent? COT? Cotangent. So also for cotangent, the period is 2 pi. All right, so let's answer these questions quickly. So what I want to do is break this fraction so that I have 2 pi and then whatever's after, okay? So we will have sine of 9 pi over 4. I'm going to break that 9 pi over 4 into this. Sine of pi over 4 plus 8 pi over 4. Will that be the same thing?
Yes.
Yes? Okay. And why am I using 8 pi over 4? Because that's 2 pi, right? So because of this property here, right here, we will say that this will be equal to the sine of pi over 4. Why? Because after 2 pi, the values just keep repeating. So what is the sine of pi over 4? We know that, right? Don't we?
Square root of 2 over 2.
Thank you. That's square root of 2 over 2. All right, let's do the next one. So we have tangent of negative 5 pi over 4. Now here, let's go ahead and use odd functions first. To refresh your mind quickly, Odd means that the tangent of a negative angle will be the same as the opposite of the tangent of the same angle, correct? Yes, that's what odd means. So the tangent of negative 5 pi over 4 is the same as the opposite of the tangent of 5 pi over 4. Now, the period for tangent, when they keep repeating the values, the trigonometric values, is every pi. So what I need to do is break this angle so that I have pi over 4 plus 4 pi over 4, and so that I can show the repeating period, which is pi. Now, if you notice, I have not lost track of this negative sign here. This negative sign came from the fact that the tangent function is odd. We had a negative sign angle here to begin with. So just quickly here to finish this up, this will be the tangent, the opposite of the tangent of pi over 4. Why? Because after pi radians, right, they keep repeating. Now, I hope you guys can remember what is the tangent of pi over 4. 1. Very good. Why? Why is it 1?
Because it
Divide the... So you divide square root of 2 over 2 by the square root of 2, divide by the square root of 2 or square root of 2. So it's 1, right? Because the sine and the cosine are the same. But keep in mind, negative, negative, negative. Okay, the next two, I was going to have you do it, but I'm just going to do it with you so we could just go out there. For cotangent, I would like you to use the following. Or do you guys want to do it? I think you guys can do it. Yes, you guys can do it. Start with cosine. Start with an easy one. Start with B. In this case, use the fact that cosine is it odd or even?
It's even.
Even. So the cosine of a negative angle is the same as the cosine of the positive angle. So start with that. Do you find the string helpful?
Mm-hmm.
You found it? Oh, okay, cool. Once you have that angle positive, break it into 2 so that one of them represents 2 pi. Something like 8 pi over 4. The cotangent, remember that the repeating period is not 2 pi, it's only pi, okay? So that angle, 5 pi over 4, break it into 4 pi over 4 plus pi over 4, so that you could say something like pi plus pi over 4. So here you could say cotangent of pi over 4. Now, do you guys remember what was the cotangent of pi over 4? Think about it. If the sine is the same as the cosine, square root of 2 over 2 divided by 2. No. Square root of 2 over 2 divided by the square root of 2 over 2. So if you divide them, you will get 1. So that will be tangent. So then cotangent will be the reciprocal of tangent. What's the reciprocal of 1? 1. Those are those little things that I tell you. My cousin tells me that like he's in engineering class, and he's like, "Oh my God, why did he get a 1?" And like everyone is embarrassed to ask the professor. So those things are good to know. All right, so this is the end of section 4.2. We're gonna go take that quick break. So go use the restroom, and then we'll meet by the flagpole to do that thing.